Thank you, everyone. Right, good afternoon to everyone. Right, before I begin, I think today is a important day for all of us because we actually started to learn security. So I picked up my security 20 years ago. So I feel very old right now in front of all of you. But nevertheless, we keep learning and continuous learning so that we actually improve ourselves. Today's topic about API is something probably relatively common for everyone to know about because a lot of you guys had heard about this many years ago. For some of the younger generations, maybe this is something that's a little bit new. We take it as a learning session today, and I would like to share with you guys some of our experience that we actually had gained along the way of our journey in career. So before we begin, I will talk about myself first. Who am I? Currently, I'm right now working in F5 Networks as a security solutions engineer. I'm focused on web application and API security, and also I also focus about automated bots and fraud detection. So that's where my company F5 is doing right now. Prior to that, I work as a professional service consultant in another vendor company doing web application security. And also I was a malware and incident escalation manager in one of the security vendor. And apart from that, I used to be a security architect, a pen tester from Ernst & Young, and also I was a trainer, right? So those years of experience seems that I'm very old right now in front of all of you. Right, so before we begin with what is API security, let's talk about what's API, and I frame you some overview of what API is about first. Okay, so this is the graph that speaks for itself, right? It is growing exponentially, phenomenally. What we see over here is that over the years, the adoption of API becomes more and more. Why is it so? Because the way that we started to use and consume applications is very different. In the past, we used laptop, desktop. Now, do you use your laptop, desktop? Apart from that, you also use your mobile devices, right? And majority of our mobile apps are actually running through API, right? Because of the way they actually been designed and the modern app architecture comes in the picture, the adoption of API becomes very relevant to us. And apart from that, let's look into and understand different types of APIs before we look into the security posture, right? So there could be public APIs. Now these APIs basically means that they are free for use by anyone. It is available for anyone to consume. Besides that, companies will set up their own APIs to be exposed out to the internet so that the consumers, their subscribers can use these APIs. So these APIs are for authorized users connecting from the external. Apart from this, we also see that between business to business, they do actually expose APIs to their partners. So this is partner APIs available basically for selected few and authorized partners where they deal with business relationships. And last but not least, we have the internal APIs that is consumed by your internal users. Example, within your universities, students consuming internal APIs within university, right? So these are not being exposed out of the external internet. This is a chart pulled out from the Gartner. And what we want to actually highlight over here is that security, API security is still the top #1 concern and challenge for all the organizations. What we see over here is that the survey showed that there are ranks and also votes being made across the multiple organizations. And from there, the API security is the top concern for them to look into. But why is it so? It's because apps modernization and digital transformation take place for the last few years. And this is so rapid that the consumption of API becomes #1. And therefore, a lot of organizations are actually trying very hard to address security concerns related to API because they realize that it is a different game rather than securing a traditional network, a traditional infrastructure, or even a traditional web application. Now here what I'm going to do is I'm going to talk about a little bit on DevSecOps, okay? And this is continuous CI/CD. And there are 6 key stages of continuous API security lifecycle. The first one will be API development. Then it goes to the API testing, right? After that, there's a third stage where we look into discover API. And then you need to build an inventory of your API. Why? You need to know what you have. Then there should be governance to your API and API protection. And this continues. Why? Because your app continues to develop, making changes. And therefore, it becomes a cycle. For API development, I believe that if you are coders, you will look into SDLC, secure coding, right? So this is actually the thing that you need to do pre-runtime, right? It's during the development time. And apart from that, you need to perform your API security threat monitoring and risk management from there to understand what you have and what you need to do from a business perspective. After that, with the API testing, there's a need to automate these tests, right? So bring in your IAS, DAS, SAS, all these tools to look into performing your API testings. Next, do identify all your publicly exposed, I repeat, publicly exposed APIs. Why is it so? A lot of times people have that misconception that I have an internal API developed and that should be safe. However, you'll be very surprised that there are a lot of application developers developing their APIs for internal use, accidentally expose the API to the public. And a lot of CISOs are not aware of that at all. And that's where the risk comes in. So you need to identify all the publicly exposed APIs. And build the inventory. Understand what you own. Now this is important and it's continuous effort. Security is not using a tool. Security is not a one-time effort. Security is a process. So you need to build this inventory as a process and continuously update your inventory. Adding security compliance governance into it. What is allowed? What are the access control? Actively monitor your API's communication. Whether it's east-west traffic, north-south traffic, internal to external, partners, business to business. So make sure you have all this governance in place. And last but not least, having a real-time detection and prevention is very important. Why? Because API protection is not only about detection. Once you detect, you never prevent it, the data is leaked, right? So the impact is being made from there. So let me introduce to you OWASP API Top 10. A show of hands over here. Had anyone of you heard about OWASP Top 10 before? It's a web OWASP Top 10, right? All of you are familiar with. OWASP API Top 10, it is the other one. And I hope that you all actually go through this in detail and you'll find some similarity in terms of how we categorize the key elements of the OWASP API Top 10. I'll categorize them into three key areas. First, access control. Second, network security. The third one is runtime protection. Now from here, you could see that Bola, the first one, the most interesting one, is categorized under the access control. Besides that, we have a broken user authentication, broken function level authorizations, mass assignment, and improper asset management. Now the last one, improper assets management, is basically known as, commonly heard as shadow API. Now you hear about this term shadow API, that's basically referring to that one. We'll talk about that later, right? And the next portion is the network security. The lack of resources and rate limiting comes to the picture. So this is one of the key top 10 API security risks that we actually look into. And finally, the runtime protection that's required. Data exposure, the misconfiguration for security settings, the injections attack, the classic one like the secret injection and so on, and the insufficient logging and monitoring. Now this portion, insufficient logging and monitoring, comes to a picture where a lot of times you don't know what you don't know. right? So you need to start monitoring that actively. So this number over here, 514, is good for you to buy some Toto or 4D coming weekend, okay? So let's look into the top 3 elements of the API security. The first portion is talking about the access control. The second one I talk about is network security, and the last one we look into is app security. So for the access control portion, what we see over here is that there's a need to manage the authorization and authentication of the API endpoints. So with this, typically what we look into is having an identity access control management to look into how we can manage that authorization and authentication. Okay, so this portion, note, if you are new to API security, our recommendation to you is look into OAuth. OAuth is the most commonly used for authorization. Next portion we look into is the network security. So network security looks into providing a secure network communications, typically using MTRS, and ensuring that sufficient network protection is being addressed, such as mitigating DDoS attacks and rate limiting. So this part address on preventing any network level attacks that potentially hunt on your API endpoint itself. Because without the infrastructure protection, your API is as good as non-accessible, non-consumable. The next layer is actually the application security. So the application security looks into mitigating common software vulnerabilities, right? And apart from that, to look into preventing API abuse. What we talk about software vulnerabilities, we all heard about things like secret injection, buffer flows. This could be still exist within an API endpoint itself, okay? And API abuse, this word is commonly heard when you relate this to bot attacks. Why? Because people are very lazy. Attackers are lazy. What they do is, if I can repeat this process, I want to do it manually anymore. I will script it and then make it automated, right? So with that, API abuse is easily achievable through bots, and bots can be very creative in terms of the way they bypass your security controls. Now, everyone is talking about this ChatGPT. I also want to bring things up too. So what I did is, a couple of days ago, I tried to log into that, and then I started with this. As a normal user, I'm interested to know what this AI ML does for me, right? So it's a NLP thing, right? So I started, can you help me to plan my Japan trip in May this year? I'm waiting for my boss to approve it, right? But well, I think yes, he will approve it. So it came out with all the itineraries for me to see. Interesting. Then now, as an attacker mindset, please help me. I hope that you guys can see it, but if it's not, then later you refer to my slide deck. I asked, how can REST API be exploited with secret injection? Well, it gives me an answer. It gives me an answer. Basically, it helps me to write the code to do the exploitation using secret injection within a REST API. And I further elaborate that with a GraphQL. Well, gladfully, it gave me some codes also, right? So in that case, the use of the AI ML comes a picture from an attacker's perspective. It's no longer about automation using bots. I need to understand an attack. I'm not in that field. I'm relatively new. I'm new in this API security. I can always ask ChatGPT. It gives me some answer. And more importantly, the in thing right now about API security attack, where so many corporates got compromised with their data leak, is because of this attack, Bola. So I asked this question, can you tell me the difference between IDO and Bola with example? Right, IDO is what? It's the OWASP top 10, right? Right, so it's an indirect object reference. Bola is the other term, Similar thing, same but different. Okay, so it gives me some example of how we can actually launch the attack using Bola. Now, after the attacker's hat is being put on, I feel I'm guilty. I put on a defender hat and say, please help me too. So with that, I ask a similar question again and see how I can look into protecting my applications, my API endpoints against Bola attack. And also ask one more question, which is, how to identify malicious bot codes that perform API abuse with sample codes? Well, it doesn't disappoint me. I didn't test it, but I believe that this Python code should work a little bit by doing some rate limiting. Okay? So what do I want to prove to you here? I want to tell you that attackers versus defenders, there's a paradigm in shift. In the past, we have human versus human, right? Okay? And after that, what happened is attackers are lazy. They started to use automated scripts. They run bots. So web application attacks can be easily achievable by using things like Selenium, Puppet, right? Puppeteer. You can script everything out, and then you could just run that to do API abuse. And this is very common right now, where we see that API attacks also closely related to bot attacks, because there's the next level beyond OWASP API top 10. That is exactly API abuse. We can see sneaker bots coming in. Do you all buy shoes? Do you go and watch Zhou Jierun? Where is your tickets? All tickets are gone before you can even enter. Why? Because they are all automated by bots behind the scene, right? So that's what happens. But of course, more serious issues and impacts for business will be things like account takeovers, like third-party payment frauds, and so on. So this is where we start to see that it is a need for the defender to help themselves with AI ML. So from a defender point, they start to use the AI ML to do learning, to be more predictive. It didn't stop the attackers also, like what we start to see over here. The attackers are actually on steroid right now. Automation plus AI ML. So we have to do continuous fight against the attackers if required too. So this brings me to the next level to share with you about API security maturity model. Now this API security maturity model is actually from Gartner, and that's something that's more interesting from your business point of view. There are 6 levels where Gartner defined this security maturity model. From level 0, there's no security. That's not what we want to land in, right? And the next level is where we start to see the need to understand the importance of API security. And with level 2, most of us already know that there's a need to in place API gateways so that they can perform traffic management, rate limiting, and also apart from that, authentication. With the fourth position, which is level 3, then organizations start to implement OAuth access control. OAuth access control. And apart from that, they also look into putting API compliance into it. That only stops at the reactive security posture. To bring your API security to the next level, what we need to do is we need to have a proactive security approach. Now, this proactive security approach means that you need to have runtime protection and API discovery. I want to specifically put this clause over here for you to understand the importance of having this level 4. It defines that there's a need to have active monitoring and proactive intervention, ensuring the compliance with the defined standards. So this allows you to move to the next level where it is actually proactive. And beyond that, we need to implement behavioral detection leveraging on AI ML. And that is actually used more of a feedback to ensure that your proactive security controls could be improved on a continuous improvement progress. So with level 5, organizations are transitioning their security and traffic management capabilities from proactive to predictive. And that is, of course, as what I mentioned earlier, the use of AI ML, where some of the organizations already started to adopt. Internally, whether they are building their own security modeling, leveraging on their own models, or they actually leverage on those security vendors to provide this as a service. So within the API security lifecycle, we always heard about the shift left because design phase itself requires to build the security from the beginning. That's where we have the design phase coming into picture. We have two important portions to look into, like what I mentioned about the 6 key stages of API security lifecycle, right? So we have the API discovery. Now this API discovery at design time is where your developers can start to document down their API endpoints that they develop and try to create their own Swagger file from there, right? So that it ensures that it is a built inventory for them to use, to consume, to know exactly what are the endpoints that they own. Besides that, the API security testing comes to a picture where there's a need to verify if there's any security issues with regards to their API endpoint that's been designed. So this is actually done during the design phase. But once you roll out to production, that's where we start to look into another terminology called shift and protect right. This is a runtime, and that's where we need to continuously discover the API and understanding whether if there's potentially exposed, publicly exposed shadow APIs. When I say publicly exposed shadow APIs, is these APIs you are totally not aware of, but yet they are exposed out in the public and they can be consumed. Now this is extremely dangerous because without awareness of this API, without protecting them, it means that you are potentially under attack. So like what I mentioned earlier, there's a need for us to look into the runtime security together with the maturity model. So I bring up these 3 stages because the first one with no security is irrelevant for us, right? So first step, you are right now in reactive security stage, okay? So how do we move towards the proactive security stage? 2 key security controls that you need to have in place, a runtime threat protection, and besides that, you need to have proper access control. OAuth is the key to go. If your organization is still using those very basic API key, forgo about that, okay? There's something that's important to look into. The next step is to move up the chain to a predictive security model. Now, the predictive security model requires you to look into behavioral security applications, security tools. Besides that, leveraging on AI ML. Now, if your organization doesn't have these capabilities or data scientists to build the model, then the advice or recommendation is look into whatever which is available in the security vendors environment and tap on them first, okay? With that, it provides you the behavioral detection and use that as a feedback to improve your security posture, okay? So this is a continuous process, and it doesn't stop in day 0 or day 1. It will continue all the way until your API endpoints is actually end of life. So something that we like to recommend you look into the API security maturity model is, this is what typically a lot of organizations are having right now. They have a WAF, they have load balancer, and they expose their API through this method to the users, right? First thing to change that to a WAP. I'll talk about WAP later, but WAP is not Web Application Firewall, it's called Web Application and API Protection. Now this is a term, technology term that you will hear from industry. It's Gartner term, right? So what it does provide is, it is looking to shadow API discovery, it looks into runtime protection, bot protection, and DDoS mitigation. The next portion is where you replace your load balancer, which is traditionally for your applications, to API gateways that is meant for your API endpoints. it does OAuth authorization, access control, and API functions. So things like rate limiting comes in the picture. And APIs nowadays no longer reside in the 3-tier architecture. What we see is that a lot of people are using Kubernetes, right? Deploying Kubernetes in our environment. I believe that there's actually a Kubernetes session, introduction to Kubernetes at the later part of this evening or tomorrow. Please attend that if you want to understand more about microservices. And that's where the need to build micro API gateways come future. And they actually are a subset of what typical mainstream API gateways are doing. It's just that they're actually within distributed environment, looking to east-west traffic protection. So besides that, there's also a need to have that brain. That brain can reside either in the cloud or within your on-prem environment, where it actually creates the model, constantly learning, and ensuring that it can feedback so that it improves your security controls. So with that, we categorize this as the proactive API security solutions, and this will be the predictive one. Now, I never put any vendor or any brand over here. It's up to you to choose. But note one thing is that you need to identify what are the different layers of security controls to be in place to put it in one piece. There could be no one single vendor to handle everything. So let's talk about the real world example of Bola right now. So Bola is basically the broken object level authorization. Okay, so this is something that is relatively easy to attack, very easy to attack. Okay, what it does is we look into an ID within the API endpoint and manipulate the ID. So assuming that I'm right now logging on as one person with ID 1, I try to see the data inside that is sent back to me, ID 1. I should be able to see my own information. What if I change the ID to ID 2? Will I still be able to see another person's information? So this is where data exposure is possible. So the object ID over here, this is an illustration. Okay, you can see that there are 5 users here. And we are just looking to the object ID to manipulate. So how it works, let's say right now I'm James. I'm object ID 1001. So when I do an authorization, I get an access token. And then I access the API endpoint with my ID. And I will receive my information. Oh, my phone number is 111-2222. Makes sense, right? Okay, I authorize to do that. But what if I start changing the ID? I change it to ID equals to 1002. That's Larry. Without proper access control, chances is that the information sent back to me with 200 OK may be somebody's information. Right? That's a simple attack. But this attack has always been there for the past many years. The recent case of telco attacks in Australia, the recent case of the online e-commerce website, they are all this sort of attack, right? So what I'll do is I'll just share with you a classic attack in Uber that's based in 2019. So how it works is like this. You can see over here there's UUID, right? And apart from that, it provides information on driver's name, role, email, telephone number, and access token. So the attacker, what it does is it sends the Larry's phone number to the endpoint that's registered as a new driver, which has the add driver in there. Okay? So you could see that there's an add driver, which is endpoint. And what it returns is with the information of the UUID. This is stage 0. And next, what I'll do is I will do a request using that UUID to see if I can actually retrieve that user's information. That completes the attack. So Bola is not only one time, but if let's say I'm able to find out the different various endpoints, API endpoints, and using those functions to fish out information, this will be successful attack. So coming back to the last portion, how do we build and plan our defense for API security? There's a need to look into distributed enforcement model. So why are we looking to this? Because it is not using a traditional approach, okay? So there's a need for us to look into how API is run on a REST API example. You send a request, you have a response. It is real time, okay? So what if an attacker start to do that? I send this request, a malicious request, immediately I get my data sent out back to me. That's a data leakage. So the traditional detect and response approach, like malware detect and respond approach, will not be applicable anymore. Okay? Why? Because there's a need to have real-time prevention in API security. You miss one step, the whole data is leaked. Besides that, as I mentioned earlier, there's a continuous improvement required. Because without that learning process, okay, you will not know that exactly your API is being exposed, particularly for shadow APIs. So which is why over here, this can no longer be applied, the typical detection and response approach. So how we look into API security? There's a defense in depth in API security that is required for. So I bring up these 5 pillars for you to reference to. Number 1, there's a need to have perimeter defense. The perimeter defense look into network level, like DDoS mitigation, rate limiting, right? Bot defense. That's a first level. And that also includes the API abuse that's conducted by the bots. The next level is the network defense. There's the use of SSL, the use of firewall, IPS. The third level is the use of the application defense. That's the use of WAP. You have behavioral detection and look into shadow API. The next level, which is the 4th level, is data defense. Having the authorization, access control in place is very important. Having data masking is very important. Sensitive data information should be masked, right? Should not be exposed. And last but not least is actually a policy and procedure when you apply your process, continuous improvement, and also apart from that, making sure that you do auditing. So this distributed enforcement model is something that we highly recommend you to look into. Now, there is also an extract from Gartner. You could see the first level where you have anti-DDoS mitigation, the ADC bot mitigation, and WAF is encompassing as one security layer. It's known as the application and network security layer. The next layer look into is where your API gateways are residing in. It provides you the access control layer. So ensuring that these 2 layers are in place will help you to address beyond what a typical API security solution is helping you on that. So as I mentioned earlier, with these 2, it means that there's a need to have a multi-layer API security platform. WAP is a new term that you need to know, okay? So a lot of people will hear about WAF, but WAF is something that's passé. WAP involves not only WAF, but it covers on DDoS mitigation, bot protection, and also API protection. So here, this is an example of where we use and adopt the multi-layer API security platform comes in picture. You could see this is an example of 2 applications, OAuth applications, client, trying to access to Juice Shop. So first, typical users will access to the app by going through an authentication process using an identity provider. So there's a need to have this OAuth server. Point number 1, this is the address to one of the OAuth API top 10, broken authentication. If one of the attacker use secret injection attack, there's a need to have application security. So application security covers on advanced content inspection, masking of your sensitive data, And besides that, there's a need for us to look into rate limiting. So it addressed the OAuth API top 10 for data exposure, mass assignment, injection, security misconfiguration, and the last part, which is actually the insufficient logging and monitoring. What if that attacker launched a Bola attack? Will these two security layers be sufficient? The answer is no. That's why we need the next layer. API access management. This is to look into advanced access control. That's to look into token validation. Because in the midst of your API endpoint, that might be token changes, token translation. Who is validating this token translation over a period of time? There must be a certain control to be in place for that. So that's where we actually look into OAuth top 10, the broken object level authorization, the broken authentication, and also the last one, which is the broken function level authorization. Can you count how many OAuth top 10 are there? Quick count. 9. Oh, yes, good. What's the missing one? I know, because there's no free prize, right? If I give you a free cookie, maybe you answer. Okay, that's the one. Improper asset management. That's what we talk about shadow APIs, right? So shadow API is not something that is easily addressable. Why? Because as I mentioned earlier, there's a need for you to make sure you first discover your API during design time, document them down, make them as an inventory, and continuously monitor your shadow API by discovering them. So with that, then you will identify the other portion of that shadow APIs. And that is actually a continuous process because you need to start from beginning inventory, analyze, discover, mitigate, export, analyze again, and then update the inventory again. Okay? So this will actually help you to mitigate threats against the shadow APIs. Some of the techniques that we look into is allow and deny requests, classic, rate limiting, classic, but it doesn't stop the attacker for persistent attack. So there's a need to actually elevate yourself to using predictive security, such as detecting and blocking malicious users, or even detecting and blocking advanced bots. So this is actually part of a solution that F5 offers, looking to discovering API, regardless whether it's internal or external. You could see from here the graphs on the top, there's some of the red color items, right? These are actually shadow APIs that we discover for our customers over a period of time. Okay? Well, our customer didn't know that they have APIs that is being exposed. And once they see that, they got shocked because they realized that, oh, there's something that really I didn't know. It was not even documented by my developers. So this is actually something that's important, another important stage to take into consideration addressing security in APIs. And apart from that, ensuring that you have the API monitoring and control is important. Inventory, update that into a Swagger file, apply the security controls in the Swagger file, apply that Swagger file into your WAP, regardless whichever brand that you have, and you enforce that for blocking, so that it can actually provide real-time prevention. All right, so that's my last slide for that, up to here. And, well, stay protected and cozy. So I actually have something to let you know. You can just scan this QR code. If you are interested to know more about our solutions, right, and look into F5, then that's something, right? Thanks, everyone.